So good morning, afternoon, or evening, wherever you are in the world, and welcome to Ubuntu on Air. My name is Jose, and I'm an Ubuntu member broadcasting live from Peru. Welcome to a QA Lightning Talk session. Today we're going to have Manuel de la Peña and Martin Pitt talking about different things. You're going to see what. So, Pitty, why don't you start ahead?
Thanks, Jose. So, hello everyone. I hope you can see my slides now. Yeah, if not. So today I want to introduce Auto-Package Test and the latest features in it. As the name suggests, this is a tool to run tests on a per package or project level. And we've been using it for quite a while to gate uploads into Ubuntu to make sure that new versions of the package still succeed their own tests and also that they don't break any reverse dependency. And it's also very suitable for things like merge proposal testing. And we've been developing it in that direction. So auto-package test is mainly three things. It's the specification of a test and its metadata, and the provisioning of testbeds, and then the machinery to run tests in the testbeds and give you back the results and so on. And I want to introduce all three of them. So for auto-package test, in that context, a test is just a black box executable. So that usually lives for a Debian package in Debian/tests. So in this example, you see a very simple test which checks core utils ref utility. And success for these tests is quite simply defined. Namely, the test needs to exit with 0, and it must not produce any standard error output. This is to catch unexpected warnings and so on. You can disable it, but by default it's strict. And the Debian test control contains all the metadata. So you see we list all the tests that we have here. So the first stanza refers to the ref test. It has a test dependency, core utils. And for simple tests, which just consist of one or two shell commands, it's also possible to directly write them into Debian test control. That avoids having to write a lot of little shell scripts. So this is just an example bogus test to make sure that etc shadow looks plausible. And since normal users can't read etc shadow, the restriction in this test is that it needs to run with root privileges. So all fairly straightforward, I hope. And since click packages are the new kid in town, I added support for specifying test metadata to the click manifest JSON syntax recently. So what you see here is more or less a direct translation of the Debian source package test that I've shown you before for a click package. So again, we see the ref test with the dependency and the shell command. So I don't want to get too much into details here. It's all documented and specified, and I think it should be quite obvious. But what I do want to show is the special case of Autopilot, because that's like the most important thing for click packages these days. So we want to avoid having to specify the full command for invoking Autopilot, because that's a bit of a mouthful, and it also tends to change every now and then, like when we switch to Python 3, for example. So instead of giving a command or a shell script, you can specify the autopilot_module key here, which gives the Python module which contains the autopilot tests. And then you can again specify additional test-specific dependencies or restrictions and so on. And for the really simple cases, like most autopilot tests that don't have any extra dependencies or restrictions, it could even look like this. So you just name your test autopilot and give it a Python module name, and it'll do the right thing. To be honest, for my taste, that's a little too magic. But since most click packages already had this test declaration, I wanted to make auto-package test compatible with that. So for almost all click packages, it just works. So the second thing is testbeds. So we want to have something to run our tests in. So the properties that our testbeds should have are that they are easily available, they should be easy to build, they should be reproducible, and they should be transient, so that each test can run in a fresh and clean and minimal environment. And also developers can easily run the tests locally and debug problems. So you see the list of available runners here. So the first three all satisfy these properties. So Chroots are fairly popular amongst developers. So pretty much everyone who has touched a Debian package should have one, and it's simple to create them. And auto-package tests comes along with scripts to easily build VMs for QEMU and containers for LXC and configure them appropriately. So it's a single command, no options. It's very easy to build them. The fourth runner is null. This is historically the oldest. And this runs tests directly on your machine. So it's obviously the fastest runner which you can get, but it provides no isolation at all. And of course, depending on what the test does, it clutters your machine with test dependencies, and if the test is very intrusive, it might even destroy your workstation. So only use this when you know what you're doing for very simple tests, which don't run as root, etc. And the latest family team member is the SSH runner. This is a very generic one, which makes no assumption apart from having an SSH connection to the testbed. And we added that in order to run tests on real hardware, mostly. So the idea is that you can specify a setup script, which creates or prepares the testbed, sets it up for SSH, and then basically gives a login name and an IP address to ADT run. This can then do its thing and run tests. And in the end, the setup script can shut down the testbed again. We currently have two scripts. One is ADB, aka the Ubuntu Touch Phone. So this takes care of disabling the first-time wizards and applying the app armor configuration and so on, and can also provide a factory reset. And the second one is Nova. So this can create and shut down VM instances in the cloud, and so that you can run tests with ADT run there. This works. It's a bit of a proof of concept, though, so it's not very robust. For production CI, we are going to use something like this, just a little more elaborate. And thirdly, how to run your tests. So how to put this all together. So this is the job of the ADT run command. In its simplest form, you just want to run the test of the Debian source package from the archive in such a test bed. So from now on, everything in green specifies what to test, like a package, and everything in blue specifies where to test it, so the testbed specification. So in this case, we are running the test of the systemd source package in a QEMU image, which provides in the topic AB64 environment. And if you run this, you'll see it's installing its test dependencies, and then run all the 5 or so auto package tests that the page contains, and you see the results here. And as you see below, all of the tests provide live output, so you see what's going on and when things take long and hang. And then, of course, you can also get a per test output and artifacts into a directory. And interesting for developers is the opportunity to run a local source package. So if you modified it or have a new version, then you can run a local DSC or source tree with this in pretty much the same way. So in this example, it's using a root or a container. And you have the option that ADT run builds the source package for you and then uses the build binaries in the testbed to run the tests against. So with a single command, you can build a package, run the test, and then shut down everything again. So the new thing is to run tests for click packages. Again, you can run them against already installed, as you see in the first 82 command here, or locally built click packages, as you see in the second command here. So the first argument is the source directory. At the moment, you always have to specify this, even if you didn't modify it. So here on the slide, we just checked out the pristine version from Bazaar. In the future, 82.1 will be able to do this Bazaar checkout by itself if the manifest specifies the Bazaar branch to check it out from. But at the moment, you still need to specify it. And again, you can say, like, run them against the install click or a local click. And this is using the SSH runner now with the setup script for ADB. So this will run on the actual phone. You have options. The ADB setup script has options for specifying a particular serial ID. If you have like the emulator running as well, and you want to test it there. Or you can also specify -r to reset the phone to factory state to run tests in a fresh environment. But please note that all test packages, test formats and package formats can in principle run on all runners. So a very interesting opportunity is to run click test in the local container, as I've shown here. So of course this needs some additional setup. So setup commands can specify a script or some commands which run before the test run. And ADT-Run comes with a pre-made setup script to install Click and the Ubuntu SDK and run an upstart, like a session upstart in the container and then run the test. So this will do exactly the same. It will succeed if you play with it. So this way it might be an interesting opportunity for merge proposal testing because it doesn't need real hardware. Okay, that was a quick rundown. So I think we still have about 3 minutes for questions. And of course, you can always ping me on RSC or ask me by email or even join the other package test mailing list. So, do we have any questions?
Apparently we do not. So probably we can leave questions for the end.
Okay, that's fine.
Cool. So now we have. Go ahead, Steve. Now we have Manuel de la Peña. The floor is yours.
Hello. So I'm here to talk about unit testing in C++. Let me know if you see the. I'm kind of useless with this Hangout thing. I put a link there so that people can. So I'm going to be talking about Google Test and how can it be used to test your C++ classes that you're either doing for your click packages or any application in general, right? So that's a quick introduction of Google Test. It's a C++ testing framework that attempts to make all tests independent and repeatable, portable and reusable, and it provides a lot of information when things fail, which is really good. And of course, it doesn't take too much work to get used to use them, and it doesn't make you do a lot of code to get the tests. That is, there's not that much code to write to do tests, and you can focus on what your tests are doing. Of course, it's fast, it's C++, and we're not going to get in conversations about which language is faster. So first things first, well, probably most of you are using CMake, or at least that's what we recommend. I don't know what click packages are doing, but I believe you can use CMake. Here, I'm telling you more or less how to add the Google Test library in your project. Now, the Google Test library, it comes in the source package. It doesn't come pre-compiled in the Debian packages. So you have to find it in your machine, compile it, and statically link it to your tests. So what you can see there in the slide is pretty much what you have to do. If you click on the link, it'll point you to a CMake module that allows you to find Google Test and Google Mux. Google Mux is not going to be covered today because that's way more advanced and takes a lot of time. So once you've got it compiled, you have to point to the directories you want to include, so to find the different headers, and obviously link your tests with the Google Test libraries. Now, excuse me. So basic unit testing with Google Test would be to write a test function, and that's done by the test macro. And you can see test macro there takes two different parameters. The first one being the test case, the second one being the name of the test that's going to be executed. Now the reason for that is because what you want to do is organize your tests per files. So let's say that all logically related tests are in the same source. So I'm testing a specific function. I have different tests for that function. I'm going to put them all together in the same file, right? So what's going to happen is that we're going to have test case name being test function A, and for example, different tests such as input is 0, and so on and so forth, right? An example of that, for example, will be a factorial function. It's going to take a number, it's returning a number, and we have different cases to test against, right? We have the default value being 0, and we have to ensure that factorial of 0 is correct, and also a positive input, for example, being 1 and 2. As you can see that we have two test macros. We have the different test case and then the test names. Now, you can see there that we're doing the expecting equal several times. Now, those are the assertions, and they're the macros that Google Test provides you, so that you can assert that certain values are what you want, right? Now, there's a bunch of them. For example, there's lots of binary comparison macros. Fatal assertions means that it will crash or will stop your test. Non-fatal assertions means that we'll get a failure in the test, but we'll continue testing. All these assertions can be used with your own defined objects as long as they implement the correct operators. We also have string comparison, for example, so we can ensure that their strings are equal or not equal. They're equal, but we ignore the case, and so on and so forth. So as you can see, it's very easy to start writing tests where you can check, my property A should be 3 when I pass X string, for example. Now, writing tests in such a manner, you can see that there's a lot of repetition. If we wanted to have different tests that have the same configuration or data, using the test macro will mean that you'll have to write every single time the same code. And obviously, if your developer is lazy and he doesn't want to do that, right? So for that, you can deal with test fixtures. Test fixtures pretty much just, if you've done Java or other languages where they have the JUnit or XUnit test case testing, it's very similar, right? We are going to write a object that's going to have a setup method and a tear down method, being the setup method where we set the different configurations, tear down where we clean any resources we use to make sure that we don't leave pointers hanging around, and so on and so forth. You can always define internal methods that you might find useful to test. So I don't know, set certain strings in a specific manner, and so on and so forth. Now, once you start using test fixtures, which by the way I forgot to mention, they have to derive from a specific class being testing test, you can use a macro similar to the test macro we were using, but that this time is going to be called test_f, and that's because simply C++ macros don't allow you to have the same macro name for different parameters, which is quite obvious for a developer, right? An example, for example, of a text fixture would be, we have this Q class over there, which is going to return the size of the class and so on and so forth, of the Q and so on and so forth, and we want to be able to write several tests for such a class, right? Now we can define a test fixture being GTest. And there we can, as you can see, we have a setup method, which is created in several queues, and then we have an empty tier down because we're not using pointers, so there's no need to clean anything up. But in case you were using pointers, for example, you will have to do that. Once we've got this classified, we can start writing tests very similar to what we were doing with the test macro. In this case, for example, this is an example case. You can see that we're using the macro. We're using the test case name right now. It's the class that we define, right? So you see GTest there as the first parameter of the macro, and then we're defining the name of the test. So obviously it's an understandable string for other developer to see what went wrong. Another example using the same test fixture would be this one, right? So here we're checking that the DQ works, and as you can see, within the body of the macro, we can use the private variables of the test fixture and so on and so forth. So you don't have to worry about that. Then that's very good. We want to have tests also that are taking parameters, right? Right now we're not doing any testing that takes a parameter. We might want to write, I know, a string function, and that string function will do lowercase, and we want to test the different cases where with lowercase, no array, lowercase string, and so on and so forth. So it would be ideal to have parameters. So you might be tempted to do the following, which is writing a method, which we're going to call a helper, and then we're going to call, within our test method, within the macro, we're going to be calling that helper several times in different ways. And that's not the way to do it. If you do that, what you're going to have is, when you do the expectation, you're going to lose a lot of data, and information about what failed. But there's a way to do this in Google Tests. And a correct way to do this, that's a big do not do previous one, it's to inherit through a pure template class being with param interface. Or if you already had tests, so you're contributing to a project that already had tests, and you think, okay, it's a good idea to put a test with parameters, you can inherit from the previous test fixture and then extend the testing with parameter interface, right? Because in C++ we can extend several different classes. The first case, for example, will be declaring our test fixture in such a way where it's quite straightforward. You can do the setup and tear down in that class without problem. In the second case, for example, I'm contributing to a project that already has a base test, and I want to write my parameter-based test case, so I'm extending it from both. And the same applies, right? We have a setup and tear down methods, and so on and so forth. Now, things get a little bit more complicated because, yet again, we have a different macro. We had tests for the simple function tests. We had testf for fixtures tests, and then we have test_p for those tests that take parameters. Now, it's not straightforward to understand sometimes, but once you get it, it's quite straightforward. What's going to happen here is that we have the same information that we had with the testf macro, right? We can access all the variables from our test fixture and so on and so forth. And we are also going to be able to access the getParam method, which is going to return the parameters. There are several methods to return the parameters. So that means that we can write a test being food test or test fixture does blah, which is my test, and then we have different those. Now, how do we pass the parameters? Because you can see there that the macro is not taking any other information. Well, we do that by another macro called instantiate test case with parameter. Now, what we're doing there in this very 3 lines is we're telling that we have my instantiate test that's going to have different parameters that are going to be passed to it. So being meaning that we're going to run that test 3 times, but with different information coming from the get parameters. That's very good if you're either doing methods that you want to do. I wouldn't call it data testing or data-driven testing, because per se you're not using a database and so on and so forth, but you can certainly hit more paths within your code by passing different parameters, knowing the function. So it's not as a purely black box testing, because you already know the different paths, but you can just inject those parameters and say, look, I wanted to be able to remove the last X number of letters from a string. Let's make sure that it works when I don't have enough characters, and so on and so forth. Now, I forgot, or I obvious the way how you run the tests, right? Now, I mentioned before that we have all the logical tests in the same file. So what you can want to do is create a main function for each of those logical groups of tests. And that main function is you'll definitely compile your test to different executables, being each of them the logical ones, which you can later run manually or tell CMake to run them for you, and so on and so forth. And the only thing you have to care about is writing those 3 lines, which will ensure that all your tests are run. So it's very straightforward in that sense. Any Google test uses Google flags, so you can pass different parameters to the initialization of your test, and so on and so forth, which are useful in some cases. So resources, I've linked to the main GTest documentation. The primer will give you a quick introduction, very similar to this one. And then you have very advanced docs where you can write your own expectations, write your own matchers, and so on and so forth. So that's it.
Awesome. So let's check if we have any questions on IRC. Apparently there are no questions on IRC at the moment, so I don't know if there's anything else you guys want to say to wrap up this session.
Do more testing.
Oh yeah.
More. Thank you. It's really nice.
Awesome.
Thanks for sharing.
Not a problem. So we'll see you next time at Ubuntu on Air. Check for future sessions at ubuntuonair.com/calendar. You can follow us on Twitter at twitter.com/ubuntuonair, and subscribe to us on YouTube at youtube.com/ubuntuonair. All our events are recorded in there, and if there are any updates, any future events, you can check them out in the calendar, and they will be posted on Twitter 15 minutes before, as always. So if you have any additional questions for the session, I'm sure Pity or Manuel will be happy to answer them. So thanks all for watching, and have a nice day.
Thanks for saying. Goodbye.